Welcome to Nugget 365 with Steve and Dana Groman, and we are wrapping up our visit to beautiful Palomar Mountain and the Palomar Observatory.
One last time, who do you believe?
They had a poster in there that said Cosmic Chemistry, and it has the table of periodic elements. Is that what you call that? It's been a long time since I was in chemistry, and I have to admit I made a C. I didn't like it.
Some interesting stuff about that table.
Well, maybe we'll get into it, and if we don't touch on it, can you tell us?
I think we should do a nugget.
On just the periodic table?
Well, some interesting things about it.
Okay. One of the main reasons for building large telescopes is to collect enough light so that it may be broken down into its constituent colors or spectrum. The analysis of spectra or spectroscopy of astronomical sources is probably the most powerful tool in understanding the physical processes at work in these sources.
It's kind of what I was saying the other day.
Right, that's what I was
Last
going to
night.
mention is we were talking about light and that you just let more light in, you can
That
see
is-
better.
That is what they're doing.
It doesn't mean you're seeing deeper.
More detail, yeah.
And more light. Astronomer Jesse Greenstein was fascinated with the elemental composition of stars. Armed with the Hale telescope, which is the famous 200-inch telescope here at Palomar, Greenstein analyzed the spectrum of hundreds of stars to assess their elemental composition. Among these stars were stars that were normal, like the sun in their chemistry, and abnormal, containing both much higher or much lower amounts of important elements such as carbon, nitrogen, oxygen, sodium, and calcium. Let me ask you a question real quick. I know this is going to be really out there, but aren't people made of carbon, nitrogen, oxygen, sodium, and calcium?
I think so. How about that?
How about that? Greenstein's cataloging of these stellar abundances led directly to a close scientific collaboration with nuclear physicist Willie Fowler. It was Fowler, together with Fred Hoyle, which we've talked about him, not such a good guy, and Margaret and Jeffrey Burbidge, who solved the puzzle of how stars synthesize these heavier elements from lighter ones and nuclear reactions in their cores.
They solved it.
When
Nice.
did Margaret and Jeff go and cut open a star?
Yeah,
Wouldn't that be the scientific method?
for everything but cosmology.
We're being a little facetious here, but not really. I mean,
No, they admit it.
truly, they make these statements and everybody goes, wow, but they can't do that. It's impossible for them to have done what they just said.
Well, all the big shots, the heavy hitters of today, admit that there's a crisis in cosmology. Scientific American even did an article on that.
And it says for which Fowler received the 1983 Nobel Prize in Physics. Well, I think the Nobel Peace Prize has not been that great of an honor for a long time. And the poster shows how they're separating these elements and pulling in the light spectrum to determine what these stars are comprised of. And you can see these two pie charts of the carbon, oxygen, helium, hydrogen, and other. All naturally occurring elements have a cosmic origin. Only the heaviest are exclusively synthetic. Hydrogen and helium, produced shortly after the Big Bang, are by far the most abundant elements in the universe.
Hydrogen and helium will fill a void, but they say it's a vacuum of space, but in space they collapse.
That's a problem. Those crucial in the development of life, like carbon, nitrogen, and oxygen, are made in stellar interiors, prompting Carl Sagan's famous quote, "We are made of star stuff." They want to say that we came from out there. Well, we came from God, who is in the third heaven, but we didn't come from stars blowing up like, what's that guy's name from Phoenix?
Lawrence M. Krauss.
What's his statement? It's horrible. You don't have to maybe say all of it, but
Well,
just say.
I don't want to say the whole part. The last part is the stars died so that you could be here today.
It's crazy.
It is crazy.
Last poster we're going to cover at Palomar, the chemical life cycle. Galaxies are the containers that hold both primordial elements from the Big Bang, no such thing as primordial elements and no such thing as Big Bang, hydrogen and helium, and the processed elements produced by generations of stars. Scientific method proof, please. During their lives, stars produce energy by transforming lighter elements into heavier ones via nuclear fusion. Stars return processed elements, for example, carbon, nitrogen, and oxygen, to the galactic environment at the end of their lives. Proof, please. And
This
they
sounds
talk
like
about-
Star Wars.
Well, it sounds like a fanciful tale. For low-mass stars like the Sun, this happens gradually, first through stellar winds and eventually as they lose their outer envelopes in the planetary nebula phase. For high-mass stars, the process is more dramatic. Supernovae explosively eject large fractions of the processed element into the environment. And do they have a video of this? Heavy elements, for example, iron, nickel, and uranium,
Yeah.
Is that what those
Yeah.
are? Come almost exclusively from supernova. The interstellar medium contains these processed elements, eventually allowing their incorporation in subsequent generations of stars. The presence of these elements in the solar system shows that the sun is a descendant of earlier stellar generations. Nope. And the carbon we inherited from these earlier stars is the basis for all known life on Earth.
Ta-da.
Voila. Hey, I think I get an A for my pop quiz for knowing what those stood for. I do remember something of chemistry. I think. I'm sure somebody will say if I didn't get one of them right.
As a pastor used to say that we knew, hog fat.
Stephen! All right. But we do know that thy word is settled in heaven, and John 17:17 says thy word is truth. And we know that Genesis 1:1 through 31 tells us of the creation, and God told us exactly what he did because he talks about how everything reproduces after its own kind. There are no fanciful tales in here.
Well, one thing we all need to remember, both sides start with a belief system. Nobody was there to see God put anything anywhere. And nobody was there to see the Big Bang. So we both start with a belief system. But after that, we've got all the science on our side. Everything reproduces after its own kind. For instance,
That blade of grass is going to produce another blade of grass.
not a tomato?
No, a star did not blow up
Much
to get
less
you
a
here.
kitty cat? No, stars didn't die so we could be here.
Absolutely not. Jesus did. And then we also had talked about Genesis 2:1 through 3. Thus the heavens and the earth were finished, and all the host of them. And on the seventh day God ended his work which he had made. And he rested on the seventh day from all his work which he had made. And God blessed the seventh day and sanctified it, because that in it he had rested from all his work which God created and made. How many times does he have to repeat that he did it? He made it.
He says that over and over. He wants us to know that.
And we should know that.
Yep.
All right. Thank you.